discuss about theorem of switching algebra. There are different types of theorem are available in switching algebra. So first theorem is known as Idempotent Theorem. Spelling is idempotent, I-D-E-M, idempotent. So what is idempotent theorem? It is a very easy. Consider one variable x. If we OR operation this variable with this variable, same variable, then the answer is x. And if we AND operation performed between the two same variable, then the output is also equal to the same variable x. So how to prove that? Consider this x equal to first 0. So from the Boolean theorem we know that if logic operation between the 0 or with 0, that means the output equal to 0, and we perform if consider x equal to 1 and perform the logical operation between them, then the output equal to also the logic 1. So that's why you can say that OR operation between the two same variable is equal to that variable. And here also if we consider x equal to 0, then the AND operation performed between 2 0 is equals to 0, and if we consider x equal to 1, then the AND operation performed between the 2 1 is equal to the 1. So that's why this x and x operation or logical AND operation performed between the two same variable equal to that the variable. So this is known as the idempotent theorem. First theorem is known as idempotent theorem. In the next theorem is known as Boundless Theorem. I again said the theorem is known as boundness. So what are the spelling? The theorem is boundness theorem, or it is known as closure of identity elements. So what are the theorem? The theorem is x OR with 1 is equal to 1, and x AND operation performed with logic 0 equals to 0. This is known as boundless theorem. So again we prove that if x equal to 0, then logical operation performed between 0 and 1 equal to 1, and if we consider x equal to 1, then logical operation performed between the two 1 equals to the 1. So that's why here if x equal to 0, then output equal to 1, and if x equal to 1, then output equal to 1. That's why you can say that x plus x logical operation performed between x and 1 is always equal to 1. And this is a very simple. If we consider x equal to 0, then we already know that the logical AND operation performed between 0 and 0 equal to 0, and if x equal to 1, then logical operation performed between 1 and 0 equals to 0. So this is called boundless theorem or closure of identity elements. Okay, it's very easy theorem. Next theorem is known as Associative Theorem. What is Associative Theorem? In the Associative Theorem we can say that the spelling is associative, A-S-S-O, Associative Theorem. Okay, Associative Theorem. So what is the theorem? The theorem say that there are two forms. One is logical AND operation, one is logical OR operation. The theorem is say that if x logically operation with y and this logically operation with z, then we can write also x logical AND operation performed between logical AND operation performed between y and z. These statements is also can be written. And this is known as the AND operation performation. And for OR operation, x or with y, with or z, this statement is also written as x or performed with y or with z, or operation performed between y and z, which is also or operation between x. Okay, so this is called the associative theorem. In the next theorem is known as simplification theorem or elimination theorem. Simplification or elimination. Simplification theorem or elimination theorem. So what is that? The theorem is, if x plus x complement is a complement of y, then we can write that this is equivalent to x or y. Okay, and in the second method, if x AND operation performed with x complement or with y, then it is known as, then it is written as x and y, because in the complement form, what is a complement? If x equal to 0, then its complement equal to 1. Complement means just the opposite logic, and if we consider x equal to 1, that means logic high, then x bar equal to 0. So this is a complement formation. This is the meaning of complement. Okay, and in the Boolean algebra, if we AND operation perform between the variable and its complement, then output is always equal to 0. And this is the AND equivalent logic. And we perform OR operation with the variable and its complement, then output always equals to 1. Okay, this should be noted. In the logical AND operation, if we AND operation perform between the variable and its complement, then output equal to 1. And in the OR operation, if we perform the OR operation between the variable and its complement, then output is always equal to logic 1. So that's why this theorem. So first of all, using this theorem, consider the left hand side. We'll prove that x AND operation with x complement, or it is also known as x bar. That means if we open this bracket, then the logic is x and x bar plus x dot y. So what is the formula? X dot x bar equal to 0 from these rules, and x dot y means simple x dot y. That means this is equal to right hand side. This is equal to right hand side. And for this theorem, if we consider left hand side, then in the left hand side we see that the term is x or x bar y. So using Boolean theorem, we can write this equation in this way. Okay, so this x or x complement y, this equation can be written as separately x or x bar with logical AND with x or y. This x or x bar is from this theorem equal to 1. That means this is 1 dot x or y. So what is the meaning of 1 dot? That means this is equal to x or y, because in a DL electronics or Boolean theorem, if we AND operation performed with 1 with any variable, so the output is equals to that variable. Okay, so this is known as simplification theorem or elimination theorem. Okay, next theorem is known as adjacency theorem. Next theorem is known as adjacency theorem. Adjacency theorem. So what is that? Two variable x dot y plus x dot y bar. This logic can be written as x. This is an AND form, and in the OR form, x logical OR operation with y, AND operation with x logical operation or with y bar or y complement. This is also equal to x. So how to prove that? In the left hand side, we here the common term x. So in the bracket, the term is y plus y bar. So what is the value of y plus y bar? That is equal to 1 from the previous theorem. So that is x dot 1 or x and 1. So what is the value of x dot x and 1? This is equal to x. And for this theorem, x plus y complement. So how to solve that? We just multiply these two terms. First term x and with x, second term x and with y bar, third term y and with x, in the fourth term y and with y bar. So x dot x, that means equal to x. This is x dot y bar. This is also x dot y, because y and x and y is the same term. This is y dot y bar equal to 0. So from this first two term, we common the term x. So this is x plus y bar. This is xy. So what is the value of y 1 or y bar? Student, it is noted that 1 or with y bar, this is equals to always 1, because if we consider y equal to 0, then y bar equal to 1. Okay, and 1 or with 1, that means we already know that this is equal to 1. This is the case 1. And in the case 2, if we consider y equal to 1, okay, then y bar is also equal to 0. Then here we put 1 plus 0, then this is also equal to 1. Okay, so that's why 1 or with y bar equal to always 1. So now from this equation, this is x, because x into 1, that means x plus xy, and from these two equation, from these two terms, sorry, not equation, we common the term x and with 1 or y. What is the value of 1 or y? 1. That means x dot 1 means x. So this is also proved the right hand side. Right hand side means this term. So this is x. So this is known as adjacency theorem. Okay, students, also note that here we common the x from these two terms, this x, then 1 or y, and 1 or y equal to 1, that is equal to x. This theorem is also known as absorption theorem. Okay, this is also known as absorption. Okay, now next theorem is a very popular theorem in electronics. It is applicable everywhere, although this previous theorem is also applicable everywhere, but this theorem is used for convert any logic to AND, for OR operation to OR operation, or OR to AND operation. The theorem name is known as De Morgan's theorem. So here two theorems are associated with. If we consider two variables named as a and b, then using De Morgan's theorem we can write that a plus b whole bar, this is also written as a bar and with b bar, a bar and operation with b bar. So here also present the third variable, but here we consider only the 2 variable. So this is also true for 3 variable, 4 variable and 5 variable also. So this is known as De Morgan's 1. And what is De Morgan's 2? In the De Morgan's 2, it is considered that the theorem states that A bar, B bar, C bar, these equals to this is whole bar equals to A bar plus B bar plus C bar. Okay, this is known as De Morgan's 2. Okay, so using this theorem we can convert different types of logic from one operation to another operation.